Hey everyone, in this video I want to address the question of why do most services deploy to a region? Or why do I do extra work to deploy to multiple regions? Or how do I deploy my AKS or app service across regions? So we're really going to dive into, well, why do we see this region level barrier for most of our services? And I'm really going to explain why we really don't want our services to just automatically deploy across regions. As always, if this is useful, a like, subscribe, comment, and share is appreciated, and hit that bell icon to get notified when I release new content or live events. Now, before we start answering this question, I think there's actually two other questions we first really have to understand. What is a region? And why do I want to deploy to more than one region? Now, we always define a region. So I can think about, okay, I've got my region. And when we think about a region in Azure, the definition is really based around this idea that, hey, there's a number of data centers that offer the services for that region that in a worst case all sit within a 2 millisecond round trip latency envelope. So my worst case scenario, if I had services on either end of the region, that round trip latency would be 2 milliseconds. And what we're going to see is this idea of latency is really the key to everything. And it really comes down to how slow light is. Now, if I shine this light and I try to race it, it's always going to beat me. Over any distance, I'm never going to keep up with light. But it is finite. There is a certain speed, and light over fiber, which is often what's happening over distances, is even slower than light in a vacuum. I think it's about 30% slower. So although light seems instant to us, it's really not. There really is this idea of, well, there is a delay when I think about travel between different regions. So if this was region 1, and then over here, I had my region 2. Now, once again, that region 2 is made up of different facilities, and it too has a 2 millisecond latency envelope. But between those regions, there is some much bigger latency. Now, that's going to vary. It completely varies about, well, which regions are we talking about? There's latency if I'm thinking about from on-premises to a certain region. And if I think about the communication, if I have things that are very chatty, constantly talking response, well, that latency gets magnified. The more communication, the bigger the difference that latency means to our actual communications. Now, Microsoft do maintain a latency map. If we jump over to this website, we can actually see it talks about, hey, network round trip latency statistics. I can click on this, and I could actually go and see, for example, well, if I'm talking about maybe, let's say, central US, if I say central US here, I can barely see that, talking to maybe central East US, so if I go and find on this line East US, well, I can see that is 25 milliseconds. So there is a finite time. So even within the US, well, there's hundreds of miles between those things. There is a finite time it takes. So it is not instant. There is actually some latency that we have to consider. And so this is an important point. The fact that there is this latency between them really drives a lot of our behavior. Now, within these regions, we often talk about, hey, there's different physical facilities. They may have independent power, cooling, communication, in which case we see them as availability zones, 1, 2, 3. That's really a resiliency feature within the region. I'm not going to talk about that in this video. I have a resiliency video where I cover all of that. But we do have these regions all throughout the world. And once again, I can kind of look at a map of all these regions. And I can see, hey, great, yeah, look, there's regions all over the US and Canada and Europe and Asia Pacific, Australia, I mean, everywhere. So this huge number of different regions that are actually available to me. So that's interesting. So why would I ever want more than one region? What would ever drive me to do that? There's really two big reasons for this. The first one is simply, hey, I have different users or services. It may not be a user, it may be some service that wants to consume whatever I'm running. Well, depending on where they are, if I'm sitting over here, for example, well, it's much nicer to talk to something close to me as opposed to something all the way over there hundreds of miles away. Likewise, if I was a system over here, for example, well, I'd rather talk to something there. So getting the services close to the consuming user or service will improve my performance. I also have to think about resiliency from disasters. Now, I talked about availability zones. They give me resiliency from a data center level failure. But imagine I have some natural disaster, some tornado sweeps in or fire, and it takes out essentially the entire region. Well, I want to essentially have my services somewhere else as well that would protect me against that. And I want them hundreds of miles apart to make sure whatever natural disaster is hitting that region doesn't hit this region. And if it does hit this region as well, I likely have bigger problems. And we'll see that with Azure, it actually does pair the regions. So these are its native pairings, and it will go through and tell you how it pairs the regions together. And the pairings are typically always within the same geopolitical boundary. It's not going to cross countries, for example. If it can help it, Brazil is kind of an exception to that right now. But it puts these pairings hundreds of miles apart to give me that protection from some kind of regional level disaster. So those are kind of the key reasons we like to use multiple regions. Performance and protection from some kind of disaster, and it could be both. Now, in ye old days, on premises, we would often have an active and maybe a backup, a passive data center. In the cloud, we maybe don't need to do that. I can just run active. We pay for consumption. So instead of having 8 active instances over here and really none active over here and have to do a failover, I could have kind of 4 active and 4 active. Gives me the best of both worlds. I'm resilient against a failure of a region, and it gets me closer to those consuming services. Now, if there was a disaster, I now have a capacity issue, so I'd have to scale up in the remaining regions, but I would have a minimal impact on doing that, and I would be able to scale up pretty quickly. So with that said, when I deploy a service, it's nearly always to a particular region. It's not, hey, deploy it to this continent, for example. Now, a VM is obvious. A virtual machine is a single compute. It can only exist in a single space. What about a virtual machine scale set, or AKS, or app service? Well, let's have a look at those for a second. And what we'll see is they always deploy to a region. If I do add a new virtual machine scale set, well, I'm deploying to a region. If I was to do AKS, a Kubernetes service, and do add Kubernetes cluster, it's going to deploy to a region. An app service plan. This starts to get a little bit redundant, but guess what? It's going to deploy to a region. A storage account, a database, a virtual network. All of these things will deploy to a region. So I can think about that region really is a container for all the different types of things I might have. So again, I might have an AKS, a Kubernetes managed service, could be a virtual machine scale set, it could be an app service, a storage account, even most of the databases. They're going to go and live in a particular region. And there's a reason for this. if I had these distributed over multiple regions, there are actually challenges with how these things work and how the communication works. Now you might be saying, wait a minute, this is not quite right. There are some global services. For example, good old Azure AD. Azure AD is a global service. It kind of spans the world, as are their various network services that I can use that once again span the world. Things like Front Door, Content Delivery Network, Traffic Manager, Global Load Balancer. Yes, they all do special things. But there are high complexities, and even Azure Active Directory isn't actually global. Azure AD by default actually constrains to a certain set of data centers in a local geography. If you actually go and create a new Azure Active Directory, why you think you're creating one that's global, it really isn't. And it tells you that when you pick a country, let's say United States, it's telling you the data centers, i.e. data centers in the United States. If I pick a different country, okay, Argentina is United States as well. If I pick Austria, well, that goes to European data centers. If I was to pick something like Singapore, if I can actually pick Singapore, it's scrolling super fast for me today for some reason. Oh, Thailand. We can see that's Asia Pacific. And I think Australia has its own set as well. So Australia. So really just these groups of data centers, even for Azure AD, it's not truly global. Now there is a way to make it globally replicated, kind of if you're a big enough company. But even Azure AD isn't really global. It's kind of a US, APAC, EMEA, and Australia. So they're very special things. And if you've ever dealt with Active Directory, there's a whole set of complicated stuff it has to deal with. Now, Azure AD is not Active Directory, but you think about normal replication, urgent replication, if you get a password wrong. There are all these advanced things to think about when you cross space, when you cross distances, because of this latency. So that's really a key thing that goes into all of this. Okay, so why can't I just deploy an AKS or virtual machine scale set across multiple regions? So think back what we know. A region is bounded by a latency envelope, i.e. within the region, we have very, very low latency. Now that's super important when I think about synchronous replication, i.e. I have some instances of my service. So let's say I've got 2 instances of my service within that regional boundary, and they have some state. So I want to make sure all of them, or at least the majority, have the same state. So we think about this synchronous replication. And synchronous replication simply means, hey, if I've got some app that's making some operation, let's say a write, for example, and if it was doing it to a database, the way it kind of works is that write that it's doing, this block of data, and let's say there's multiple copies, so it kind of makes the write, it sends it over to the other copy where it makes the write, it acknowledges that it's done the write, and then this would acknowledge it back to the app. So that makes sure I can't lose data. It's synchronous. So this is what we consider asynchronous because it writes to multiple places, a majority, before it acknowledges. That's different from asynchronous, where the idea is, hey, once again, I have some app. Once again, it's doing some operation, let's say a write. And once again, I have multiple copies, but maybe now it's a much bigger distance, which makes synchronous non-optimal. Remember, these are very close together, so this extra time to talk to this copy, let's say it's a millisecond, doesn't really impact the speed of that operation. So I can update it, make sure it's there before I acknowledge. Well, here I'm going to write it and I'm just going to acknowledge it straight away. And then kind of lazily in the background, send it over here. Well, I'll get an ACK just so I know, but I don't do anything about the app. So this is asynchronous. And this is good for long distances because this time, let's say it's at 25 milliseconds, doesn't impact the performance of the app because it gets an ACK straight away. Downside is, well, if something happened before it replicated, I might lose this data. So it's always the trade-off you make between these services. So, okay, what we know is within a region, we can do synchronous replication because we have those very, very low latencies. And that's super important if there's any kind of state to that service. I know I can have this durability to that state. Now, the other reason is, think about it, well, I like to have multiple regions so I can have resiliency from something bad happening. Well, if I think about that, many services actually have some kind of control plane. And if I'm deploying to multiple regions, I do not want something on this region depending on something on this region to operate. Because if it went down, it doesn't work. These would no longer function. So let's think about a typical service. I can really think, okay, there's that control plane and then the actual service itself. So AKS has Kubernetes service. It runs for us, we don't manage it, but it's running there. So there is a control plane that is running in a region, and that has state. So it has to be able to make that state durable for it to function. And then, sure, we can add, for example, we add worker nodes that talk to that control plane. And that's all good. They're close together, they're running in that region. If we actually could add kind of worker nodes in another region over here that talked to a control plane in another region, even if this worked, even if I could have different configurations because there'd be a different network over here and other resources, if there was a failure in this region, I can't do anything. They may continue running, but I can't do any management around them anymore. I couldn't scale them. I couldn't change anything. I don't want that. That's not a good place for me to be in. So this is not an attractive. I do not want a dependency between regions. I want resiliency. That's the whole point of this. So this is not a good situation. I have zero interest in being in that scenario. It's much better for me to have a separate control plane on here. Also consider control planes could have a problem. I might deploy something to the control plane and it fails. There's a bug in it. By having a separate control plane over here, it wouldn't be impacted by the same bug. This would carry on running. So I don't want that. So even if I could stretch the control plane to another region, even if somehow I could handle its state to the other region, I don't want it. Because if something happens to the control plane, then that can absolutely happen. I'd then mess up the other region. I want an isolation between not just the compute services, but the state and the control planes. That's an attractive thing. We want that separation. I don't want a single control plane going across my different regions. Now you can really just keep expanding on this. If you think about other constructs, for example, we have a virtual network. A virtual network is bound to a region. It's a certain IP space. Now you might say, well, why is that bound to a region? It's just a logical thing. But again, think about it. Hey, I create a virtual machine that has a customer address, a CA. That's not a real address on the real network, remember. What actually happens is this is actually sitting on a physical box, a host. And that has a provider address that's real on the physical network. I might have another VM over here that has a different customer address that sits on a different physical box that has its own provider address. And there's an entire control plane, the network policy manager, for my software-defined networking. And that software-defined networking has this whole customer address to provider address mappings. And it has to distribute those mappings to the host. There's a state. So that's an important thing. I have all of that. And so once again, the better option is to simply have, hey, I'll have a different VNet over here, where it can have its own addressing and its own mappings. And if they need to connect, great. I can do peering, where now it's kind of a BGP and a sharing of addresses. The other reason I might want to keep them separate is, hey, I still have on-premises. I might have an on-premises location, for example, over here, and I have one over here. If it was one big VNet, it's very hard to distinguish, well, what paths they should take. I may have different express routes for different locations. So it's attractive to me to have those separated over the region so I can control the paths they take. I might still have them connected for resiliency purposes, but I like that idea of them being separate. So the VNet itself is bound to a region because it has state, it has these mappings, but it's also beneficial for me, so now I can really define granularly what paths it might take to other networks, how that would actually connect to them. Other resources. I mean, you think about, hey, I have a load balancer. If I create a load balancer, for example, well, that load balancer behind the scenes, there are SDN components like the muxes that power it, a ring of those. They exist in the region. So even if it could point to something over here, it's not good for me because if it failed, it wouldn't work anyway. Remember, I don't want cross-region dependencies. Its front end might be a kind of a private IP from within here, or it might be a public IP. Public IPs, guess what? They are bound to a region. There's bigger routings on the internet to find the particular physical networks they live. I can't move a public IP address between regions. They live in that region. And it carries on. A storage account. Hey, a storage account, guess what? That's bound by a region because it needs to store 3 copies quickly in a majority when I do the write. That same thing we saw about the synchronous. Now, yes, I can geo-replicate to another set of copies where I have another 3, but this is asynchronous. I can make this read-only, but the read-write only goes to this copy. If I was thinking about relational databases, same thing again. It's all about the state. When I do a write of the data, there's multiple copies to it, but I do some write, well, this primary is read-writable. I can add secondaries. I can maybe even make them read-only. And once again, there's going to be this asynchronous replication to it. But I couldn't just deploy the database across regions and close my eyes, because if this was synchronous, remember that performance, it would destroy the performance. I sometimes will even have local read replicas. For my applications, can now do the reads from this one, read writes to this one to optimize and take some load off of it. But it really does apply to everything. Cosmos DB is a little bit special. Cosmos DB lets me, if I want to, have multiple read copies, but then it's still not synchronous. I pick a consistency. If I say strong consistency, i.e. synchronous, it's not multi-write anymore, and it's going to impact the performance. So I get to pick the trade-off with that consistency, the whole CAP theorem stuff with Cosmos, but it can't cure the speed of light. I cannot have all of the data consistent and have no impact on performance. Until we have kind of quantum entanglement and we have the same 1 and 0 in 2 places at once, this speed of light is always going to be our factor. When I provision my resources, I have some image store. I think about, okay, I have an image store here with maybe my VM images, maybe my container images. And what we want to make sure is, once again, we replicate that, but it will be asynchronous. I want a copy of that in my other regions I use in case I need to provision more things. Now, often there are options where I can tick a box to say, hey, I want copies in these regions. Things like your repos, like GitHub, Azure DevOps, your repos actually are typically just replicated for you. I generally don't have to worry about that. They kind of just make those available and they do the replication for me. But obviously repos are important as well because, hey, it might have my code in it. It might have my infrastructure as code in it. I'm going to have all those different things. And it just carries on, carries on. But this is the key point. The slowness of light is really going to impact how I deploy things. Now, there is another reason for this. There's another reason I wouldn't want it to just deploy across regions, and that is my own app architecture. Now, when I'm designing my app, I might have multiple tiers. So I might have kind of, hey, I have some front end. Great. And I probably got a load balancer or something in front of that. In fact, let's give myself a little bit more space. Let's say we go down here. Great. Well, then I probably have a middle tier. So now I have some kind of middle tier. And the way that works is that probably has some kind of load balancer that these talk to, which distribute to these. And then maybe there's some kind of back-end database. Now, when I talk to databases, they might have different names for like a read replica, as we talked about up here. There might be different listeners, and I say my intent. Is my intent to read write, or is my intent to read only? And it will point me to the most logical one. But for my own app architecture, well, imagine I want to go to different regions. Well, I'll have a different copy of that over here. And that's super important because what I wouldn't want to happen, I'm going to get this really lazily here, is you want the tiers to talk to the right one. I wouldn't want a front end here talking to a middle tier over there. That would kill my performance. I want to keep them local if I can. Now, the reason we have to do some special considerations is this data. Because remember, for a relational database, really only one of them is kind of read-write. I can have a replica over here, and maybe it's read, but I have to treat it slightly special. These kind of workers, this middle tier here, it might be able to do the reads from this local, and maybe read is 95% of the work. But if it needs to do a write, well, the writes have to go to this one. And if it then did a write and then a read straight away, I have to be consistent. It has to know, well, to do the read from this as well, if I've just done a write. So there's logic that I have to put in. So it will be no good if the service just auto-deployed blindly across regions. I have to be able to very specifically control those elements to make sure I'm doing the right thing. I might use a cache. I could pre-populate the cache. I could warm the cache up in advance. But I have to do the work. So it's actually a much, much better architecture for me to independently deploy across regions. So an instance in this region, an instance in this region. That gives me the control. I can then manage where is the state. I've got that independence of things like the control plane. So if something did happen, I'm not impacting my other instances of the service. So I do not want that. I want complete isolation between my various deployments. Now, ultimately, there is still something consuming this. So this is where you combine it with some kind of global service. So I can think about, hey, there are these kind of global services. It could be front door for HTTP workloads. It could be the global load balancer for layer 4. It could be traffic manager for DNS. And then it can point to the regional instances if they're public facing. For internal facing today, you'd have to do some kind of network virtual appliance. And these have special capabilities to actually be global, and Anycast or traffic manager is just DNS to make them globally available. Now you might say, well, okay, I've added that layer, but this is a horrible experience for me. I'm having to go and actually create multiple instances of services. That's a lot of work. It's really not. If we go back up a second and look at these kind of repos, what we really want to be doing is kind of infrastructure as code. So I have maybe JSON templates or Terraform or Bicep, and they're kind of replicated all around. And I just have a template. I'll have regional level parameter files. I tweak a few settings like the VNet name and maybe an instance it talks to, but I'll use that to actually provision. I'm not manually clicking buttons, so I can very easily provision multiple instances in a very consistent way through there. It's declarative. This is what I want to be there. And it's just going to go and deploy those. I might have CI/CD pipelines that do this for me. Now remember, CI/CD pipelines might have agents that actually do the deployment. So I may need to think about having agents in multiple regions for that. But I can really take away the pain of this. Yes, I have to think about this. I have to think about, hey, there's multiple regions, and when I have databases, I have to think about, well, okay, if it's not Cosmos, and I'm not using like a session level consistency, okay, there's reads from here and read write, but that's life, that's architecture. I have to handle the fact that light is not instant. I can't have it synchronously available. I have to weigh those things up in my architecture. But the whole point of multiple regions is that resiliency. So I don't want some shared control plane. I don't want any shared dependencies. So that's fundamentally the answer about it. Blame light. It's really not that quick. But this helps us have the best experience, the most resilient services, by having them separated, by having us deploy different instances, but by using things like infrastructure as code, CI/CD pipelines, it doesn't really add additional work to me to do and maintain the environments. This is what I want to be there, deploy it twice or 3 times or 4 times. It's not a huge pain point. So that's the answer. That's why things just don't automatically deploy across regions. One, there's pain because of the state, but also we really wouldn't want it anyway. It's better for us to have that control and have those separations so I don't have any cross-region requirements or dependencies. And that's it. Hope that was useful. Hope it answered the question of why I can't click a button and have AKS deploy across multiple regions. The answer is you can do. You just write that pipeline yourself and it will do it. Till next time, take care.